Hey, have you ever wondered how electric charges affect the space around them even when you can't see anything? Well, today, we're going to see the invisible as we explore electric fields, electric flux, and Gauss' law. Let's start by visualizing electric fields using field lines. Electric field lines show both the direction and strength of the electric field. For a positive point charge, field lines point outward. For a negative point charge, field lines point inward. The closer the lines, the stronger the electric field. Note that the direction of the electric field is defined as the direction a positive test charge would move. The magnitude of the electric field created by a point charge is given by E is equal to K multiplied by the absolute value of Q over R squared, where K is Coulomb's constant, Q is the point charge creating the field, and R is the distance from the charge. For example, if the point charge is equal to 2 times 10 raised to negative 6 coulombs, and the distance is 2 meter, therefore E is equal to, remember that the value of K is 9 times 10 raised to 9. 9 times 10 raised to 9 multiplied by 2 times 10 raised to negative 6 divided by 2 raised to 2 will be equal to 4.5 times 10 raised to 3 Newton per coulomb. Since our point charge is positive and the test charge is always positive, therefore the direction of our test charge will go to the left because positive and positive will repel each other. Electric flux measures how much electric field passes through a surface. It depends on the magnitude of the electric field, the area of the surface, and the angle between the electric field and the surface. The equation for electric flux is pi sub E is equal to E multiplied by A cosine theta, where E is the electric field, A is the area of the surface, and theta is the angle between the electric field and the surface. When the electric field is perpendicular to the surface, the electric flux is maximum. When the electric field is parallel to the surface, the electric flux is zero. Fun fact: Carl Friedrich Gauss was known as the Prince of Mathematicians. As a child, he amazed his teacher by quickly adding numbers from 1 to 100 using a clever pattern. Later, Gauss made major contributions to mathematics and physics. His work led to Gauss' law, one of the most important ideas in understanding electric fields. What is Gauss' law? Gauss' law is a law in electricity that explains the relationship between electric charge and electric flux. It states that the total electric flux passing through a closed surface is directly proportional to the total electric charge enclosed inside the surface. In equation form, pi subtotal is equal to Q subtotal over epsilon naught. This means if more charge is inside the surface, more electric field lines pass through it, and if no charge is inside, the total electric flux is zero, even if electric field exists outside. For example, if we have charge 1 is equal to 15 coulombs, charge 2 is equal to negative 5 coulombs, charge 3 is equal to 10 coulombs, and charge 4 is equal to 20 coulombs. The epsilon naught is equal to 8.8542 times 10 raised to negative 12 coulomb squared per Newton dot meter squared. For our surface A, we have charge 1 and charge 2. First, we will distribute the values in the equation, wherein 15 plus negative 15 is over 8.8542 multiplied by 10 raised to negative 12. And our answer will be 1.13 times 10 raised to 12 Newton dot meter squared per coulomb. And we will repeat the same process for the others. And that's it. Physics may be invisible, but equations like this let us see the invisible.